Yes, so the plan is to have a sort of an open discussion on the human exploration session. If anybody has thoughts or...
Well, I'll start with one.
Okay.
I'm looking for Ariel. Is she still? Where's Ariel? Well, that ruined my question, Jim. Come on.
Okay, I can go get her, though.
No. It's fine. I was curious if there's anyone else who participated in that discussion that she had. I was wondering if there was anything that we talked about here today, or actually anything in this conference that would change the decision tree that they went through.
I'll go get her.
Okay. While we're waiting, any other observations or points that people would like to bring up from what they heard this morning, particularly or as it relates to any other topics we've discussed so far? Go ahead.
Hi, I'm Michael Sims, and I'm from the Mars Institute. Those that don't know me, I've done a lot of operation of rovers all over the Earth and on Mars. So I wanted to make a comment about Michael Wright's talk. And I'm very much an advocate for human exploration of the Mars system, both orbitally and the surface. But I think the one justification that really doesn't carry itself is that the time latency allows you to do much better operations. And so I'll go back to a study that Roger Berg and Donna Privarato and I did 25 years ago, which is buried somewhere in some JSC publication somewhere. But basically, if you just simply do counting for most reasonable missions, if you count the cycles and you look at a reasonable level of autonomy, and we use the level of autonomy from Pathfinder, right? And it's just that Earth wins, right? By the end of the mission, in typically a relatively short stay in the Mars system, Earth wins in that trade. And the reason is that is sort of what Mike was getting at in his talk earlier. And I really appreciate what they did, because it's a lot of details of stuff that you have to actually look at carefully. But if you look at those details, what you find is that, yes, it's really hard to find time to do the operations while you're there, but even if you assume 24 hours full-time operation, 24 hours on one or two people, whatever you want to do, you have however long you're in orbit, a couple of months, and you have another month or two where the latency is still low. If you contrast that with the 2 years or so that you can do on Earth, and you use a reasonable level of autonomy, which is Pathfinder, right? MER is even more, and it's even, in MER, the autonomy in MER is about 25 years out of date with what we can do on Earth, right? So the bottom line is that there are lots of great things you could do, and one of the things, there are a few things that are actually really valuable to be in orbit for, but there aren't many. Most of the things with the kind of operations you do for MER, you could actually get it done and back. So, and it's interesting to look at what the limitations are in MER. Limitations in MER, the fundamental biggest ones are power and communication. It's bandwidth to get it back. Those are the big things driving the efficiency of the operations there. And a little bit more autonomy, and they would be very efficient. So let's by all means send humans to Mars, but I think let's not bury that upon an assumption that because there's lower latency, we're going to have a lot more effectiveness out of the operations.
I would say a couple comments. We did a fairly in-depth study about which task would be best. And you're right, the scientific tasks didn't rate that high because you could do them. I mean, you could do them faster with the crew there. And some of the tasks that rose to being important are things like excavation, where you're dynamically changing the environment, where it's really hard to automate it and so forth. So where we got to is we wanted to talk more with the science community about how we would design these rovers to take advantage of the crew. And certainly we could go a lot faster and do things. But you wouldn't do that at the exclusion of the ground being able to operate the same rovers over a longer period of time.
And let me add to that as well. One of the ground rules that we went into these series of studies that Mike Wright was reporting on was an assumption, in Mike Gernhardt mentioned it, that we were doing conjunction class missions. So the crew is in the Mars vicinity for on the order of 500 days. So it's not so much that we thought that, well, I'll speak for myself because I don't know, I'm not going to put words in other people's mouth, but since we had a crew there, we were testing the hypothesis, could we take advantage of the fact that we had human beings within a relatively small communications distance? The answer turned out to be no, then we're not going to risk assets doing that. But if the answer is yes, then we have 500 days potentially worth of a very capable asset in orbit that can work with the robotics devices in various places on the surface. So that was the hypothesis, if you will, that we were trying to test and see how well we could do or what we could do. And the ones that turned out to be beneficial, we'd keep those in the mix and go forward with them from there. Okay. Mark, did you want to comment on that one, or otherwise I want to go back to Ariel?
No, go back. I'll have some
Okay.
different comment.
I don't know if Pascal whispered in your ear, but I was curious if you saw anything over the whole conference, actually, that would have changed. Would you add, subtract, change any of the pieces of your decision tree that you came up with in your previous discussions?
I think that some changes that perhaps we could think about would be, there are a couple of extra things we didn't account for that we would need to assess. There was talk yesterday on charge and static and how that can affect on the astronauts as well as the equipment. So that would be something that I would add into assessing the safety. I think that while at the top of the flow chart where we have more of a science exploration, it's important to keep aiming for the characterization of both bodies, but perhaps once we get to the boxes that are more focused on the exploration, those should probably just be detailed specifically to Phobos. Engineering-wise, I think that's the better option of where to actually send humans. And then, other than that, I think that a lot of the talks today have just really encouraged the idea that we could get humans there. A lot of these questions are being addressed in research, and for instance, we pointed out the need to quantify the radiation effects, and Mike presented on that, and thinking about where on the body would have to be or how far in the crater, how that would decrease radiation. So some of those boxes really are already starting to be ticked off.
Okay. Anybody want to continue that thread for a moment, or if not, we'll move on to some of these other topics. No? All right, thank you, Ariel. I think you were next. Then we'll go over here to Mark.
Okay. So I like Phobos and Deimos because I like Phobos and Deimos coming from the small bodies end. And they often seem to fall between, people who study asteroids go, well, there should be a mission, but it should be under the Mars folks, they should pay for it. And the Mars folks say, well, these are really small bodies, and so we don't really care about them. The question I would have is, in thinking about Phobos and Deimos as a stepping stone to put people on Mars, if it's decided that they're not in the critical path, if it's decided that we're not going to do that, we're going to send people straight to Mars, does that likely preclude ever sending people there? Is it possible, are we going to end up in a situation where by focusing on putting people on Mars, we're cutting out Phobos and Deimos? Or are things likely to be flexible enough that at some point we could say, oh, great, now we're going to have a particular expedition go to Phobos and Deimos? I recognize that's not, this is not like a promise, asking for a promise, but just sort of the way things look.
A lot of it depends on the funding and so forth, and I made the argument that it's on the way to Mars, it makes sense to go to Phobos. If we did what we're looking at now, which is Mars surface on diet, like a really simple one, I wouldn't rule out that with the transportation infrastructure and so forth, that we could come back later and do Phobos and Deimos. And then you can even reverse it where you're doing LLT of assets on Phobos and Deimos from Mars surface. If we're stuck in one place there, after a couple missions, it's going to get kind of boring.
If I could just add, it just depends also on what our posture is in the Martian system in the long-term exploration / pioneering / settlement. We may be able to do a first expedition to the Martian surface directly, although I'm a fan of going to the moons initially. But if we do a sustained presence, we may use the moons as a staging point, very possibly if there's resources to be able to guide there.
Okay, yeah, it would be too bad if, just like it's kind of in a hole between small bodies and Mars, if it then fell in a hole between robotic and human and no one ever gets to.
And I don't think it's that, the answer is not that simple, and it will depend on many factors. So, it will depend upon where we get to at the time. So let me go over here, unless you want to continue with that thread, I want to go over here to,
But I think I'll continue the thread if it's okay, just in a sense.
well, go ahead.
So what I was going to comment on was this idea of the stepping stones between the planets, that and not just for Mars, that our own moon could be a stepping stone into space too, and partly the in situ resource utilization, and considering that you could think of these as space stations of sorts that are easy to get to, maybe from the surface of Mars, and get down to the surface of Mars. What occurred to me was that, if you take the inner moon Phobos, you are kind of energetically limited, or you would favor low latitudes at Mars. So if you take these as places to go, if you work from the other direction, assuming that you want to use these stepping stones, that might influence your selection of where to go on Mars, and to go to an equatorial region, to go to Valles Marineris or something, that's interesting there, because then it's easier energetically to get back to your base. So it could even, influence that whole strategy. And the other, if you do want to go to high inclinations, then you might want to go to the upper moon as being an easier base to explore Mars from. If you want to go to the poles, your energetics for launch and landing, or at least for launch from the Mars, are much better to go to Deimos than to go to the.
I would just add,
Yeah.
that when we started this, we had this sort of hope that Phobos would be, we had the base there and the stage of Mars.
Uh-huh.
That didn't pan out.
Right. Yeah, depending on where if you wanted to go to the equator, it would be perhaps okay. Yeah. I guess the other side of that is that if you were. Right. But the other side is, if you get your propellant from ISRU, then it changes the equation, right? And it could be from the moons itself rather than from the surface of Mars. So.
And Tim Sheehan from Lockheed Martin, and in our Mars base camp idea is, we looked at the surface of the moons for the base camp, but we kind of tumbled to being in orbit to have a lot of benefits. So, and I think one point is though we don't necessarily want to miss that opportunity, because developing systems to land and get back off on Mars is going to take time and money. We shouldn't pass up that opportunity to have human exploration of these moons, because just that technology demonstration and mission demonstration of pushing off to Mars is so valuable, and we're a big advocate of that.
Let's go back over here.
Like Red? So I'm John Cooper, a radiation planetary guy at Goddard with the Dream 2 team. Very interested in your talk, Michael. Sign me up. I want to go. On radiation, you should know that the older guys, have less of a risk of radiation, right? So, you should sign up for that. So I wanted to ask the details a little bit. You talked about the PEV being covered by the 500 pounds of water. About how thick is that?
Yeah, and that number actually came from the lunar base, and it's for SPs, not for DCR. And I think this is 4 inches.
4 inches. Okay.
And we work with Langley and Frank.
Yeah. Okay. I assume you're not going to want to be. You talked about a crater hopper, but it sounds like the mission you would probably do would be kind of more of a flatlands kind of thing. Is that right? You talked about a crater hopper, you know, that the HAB or the personal vehicle can hop around.
We got uncomfortable with taking a path in the crater and things like that.
Yeah.
That's why we used the PVD, which is highly maneuverable.
Yeah.
It basically flies and hops, and with the operators to be stable on the crater wall and so forth. So we'd actually do our exploration from that.
And so then I would suggest that, you know, the time that you spend in a crater could be very nice from the point of view of radiation.
Sure.
Because, you know, then you've got a roof on top of you and you've got walls around you. And
It's a calculation that I showed.
Yeah.
It's
Okay.
One thing that I wanted to talk to the last presenter that I have to be honest, we haven't really exhaustively run the thermal analysis, and we need to look at that in terms of how hot it might be in the craters and so forth. What that means.
Thank you. All right, let's come up, Carly over here.
Yeah, my question is probably mostly for you, Michael, but it's unfortunate that the Lunar Grad Con's going on in parallel with us, because that's where all the young people are. Younger people are, excuse me. But in your overall analysis, which is very detailed and wonderful to see, what about precursors? I'm thinking about when we went to the moon, we had surveyor, we had orbiters, we had a range of precursors, which clearly there must be some, and that was the first item in what the students brought up. So was that something that was discussed, or when is that going to fall in the sequence?
I have a presentation on that, and we can start this year. We
Yeah.
actually wanted to have our precursor with a orbital angle landing asset there by
Mhm.
2022 to support the design.
Oh, yeah.
So we're behind the curve. We're excited about the Japanese mission and the
Yeah.
NASA mission, and we've got we're fairly far along on the kind of landers that we need, which
Mhm.
because we love, it's good science, but we want it to go to all the areas, so we could be a hopper, kind of running and get it. We want to rule out hazards and things like
Yeah,
that.
you want answers first, yeah. Yeah. Yeah.
If we went there without the precursors, we would be at a lot of risk.
Yes.
Yeah. Yeah.
Yeah, I think it's one of the things that Paul Abel from NASA Johnson, that working with Mike, that we recognize the importance of precursors for this type of mission. And so we would have, you know, an orbital campaign and then a series of landed situations where you would go and actually characterize the surface for strategic knowledge gaps, but at the same time get a lot of science as well.
Pascal?
Yep. So about 12 years ago, we wrote a very short paper that actually had in its title that Phobos and Deimos were on the critical path to going to Mars. But the argument there was that it wasn't sort of an engineering critical path. If Phobos and Deimos didn't exist, would we know how to go to Mars? Well, I think we would, of course. The argument there was essentially what Mike brought up earlier as well. It's sort of a programmatic argument. If Phobos and Deimos are there, and they are such exciting objects inherently, because we don't know what they are still, and there's going to be plenty of mysteries to resolve, they offer really an exciting midterm target to have us focus on. And by going to Phobos and Deimos, we will be going to Mars, because obviously we'll be in Mars orbit. And one idea that has come up not at this Phobos Deimos conference, but at the previous one, I think, or possibly even in the first one, was an idea by Phil Stuke. And Phil suggested that what we could do in the 2020s is to have a campaign of Mars sample return with samples collected in different regions, of course, on Mars, but not brought back to the Earth. They would be brought back to Phobos, cached on Phobos. And the idea is that, sample return is always fraught with this planetary protection concern, especially if you're looking at places that are promising for the search for life. And if you are caching your samples on Phobos, now you're going to be allowing these samples to sit essentially in deep space, radiation, insolation for several years to a decade. And then all of a sudden, this collection of Mars samples that you have cached on Phobos are going to be an incredible motivation also for astronauts going to Mars orbit to return. Because in addition to having the Phobos science, Phobos Deimos science to return, they would also have a specific cache of Mars samples to bring back, which would have been quarantined for a long time on Phobos. So I just want to throw that idea into the mix, that if the 2020s were dedicated to collecting samples on Mars and bringing them back and caching them on either Phobos or Deimos, that could be a very exciting additional agenda item for humans to do in Mars orbit.
We actually had plans to do that.
Yeah.
The other note to add, maybe a little better, but we did an informal survey just to see what the public thought about going to Phobos or Mars, and we were surprised, but most people don't know that Mars has moon. And most people thought that would be harder to go to the moon of Mars than Mars because of the difficulty of the follow, etc. So I think it would generate a lot of it's a monkey's treasure, so to speak. And I think this is a thing as well.
Yep. And I don't want to hog the airtime here, but there's another thing that was brought to my attention when we worked on our Discovery mission proposal, which is Phobos and Deimos are the two known moons of Mars. Dynamically, Doug Hamilton, Mark Showalter have looked at this. There could be smaller moons that could still be stable in Mars orbit between Phobos and Deimos. We don't think that there's anything larger than 10 meters outside of Deimos. But between Deimos and Phobos, because they would be lost in the glare of Mars, there could be objects still that are between 10 and 100 meters. And below Phobos, there could be objects that are up to 100 meters in size that would be undetected, essentially, still. So I'm not suggesting that that's something for humans to look for. I'm saying that there's plenty about the circum-Martian environment we still don't know that could be adding to the excitement of going there. Those could be interesting targets for humans if they existed.
So there were multiple talks about rovers on Mars itself and on Phobos. And on the Mars one, there was a talk about a scouting rover. And the Mars 2020 rover uses a vehicle that flies ahead of the rover itself to understand the terrain. And I'm wondering if that sort of thing would be considered for both Mars and for some sort of similar device for Phobos.
Absolutely. In fact, in our ideal world, we would have our precursor lander there, and if it lasts as long as we hope it would be available for us to do that scouting rover on Phobos. And then I briefly touched on the fact that a high-powered, low-mass scouting rover would be optimal for cruise time for Mars surface operations. And we're starting to work with the science team at USC and Goddard to figure out how you would coordinate this versus with the scouting rover and then more capacity.
Just a comment, Victor de Maria from European Astronaut Center. And I had a thank you for your presentation. And the comment is because somebody was talking about sending the robot or sending the human. And as an AMD in charge of the training the astronaut and following the healthcare of the astronaut, for us it's really, really very important to continue to work with you together from now. Because for us it's really important to take care about all the medical contingency of the astronaut going there. For us it's to send the guy there to work and to keep them in good health and coming back here home. And we need all the information, we need all the result that you have from now to prepare the mission, the human mission to Phobos. That is a message that maybe I'm the only MD here, which is a strange word for me, but the message is this: we have to work together. Don't forget the doctor taking care of the astronaut. Thank you.
Pascal? We're running a little bit past our scheduled time. I think we can break for lunch now. Pascal, what time do you want to reconvene in here?
What o'clock?
So 25 minutes for lunch. And then
Okay, sorry. I was assuming everybody was staying here for lunch, but, yeah.